Welcome back, everyone. Today we're going to be looking at the properties that really differentiate the three states of matter, which are the solids, liquids, and gases. We'll start with the basics. There are three states of matter, and they can be represented by different properties of their molecules. So just look at this image really quick and try and decide for a second which of these images, this one, or this one, is a solid, which of those three images would represent a liquid, and which of those three images would represent a gas. Try and keep that in your mind, and you will discover the answer as we progress through this presentation. So as we've already stated, there are three states or phases of matter. There are solids, liquids, and gases. Start with solids. Solids have a fixed shape and a fixed volume. And what this means is that if something exists in the solid phase or the solid state of matter, it cannot change its shape. Its shape will not change unless if there's some force applied to it, and its volume will not change, no matter what. Solids are the lowest energy of any of the states of matter, and the reason it has the lowest energy is because the atoms that make up that state of matter are the slowest moving. In fact, the atoms in a solid are moving so slowly, so the atoms, you could also call them particles, atoms/particles, and solids are moving so slowly that they're locked in place. They cannot move past one another, and this is why solids have a fixed shape. Sometimes you'll also see, instead of fixed, the word definite. This also just means that the shape cannot change. There's a term that describes something that is in the solid state, and as you may have guessed from the clue, anything that is in the solid state, not just water, can be described as frozen. So the desk that you're writing on is frozen. The pencil or pen that you are holding is frozen because they all exist in a solid state. Next up are liquids. Liquids also have a fixed volume, so the amount of the liquid won't change, fixed volume, but liquids do not have a fixed shape. If I took a glass of water and I dumped it onto the desk, there would still be the same volume of water, but it would take a wildly different shape. It would spread out across the desk. We say that liquids take the shape of their container because they become the shape of whatever container is holding them. In terms of their energy, liquids have higher energy than solids do, so higher energy, but less energy than gases. They're kind of the middle child of the three states of matter. And then again, with atom speed, or how fast those molecules are moving in a liquid, the atoms move faster than in a solid, but more slowly or slower than gases. What really makes it a liquid is that now the atoms have enough energy, they're moving fast enough that they can slide past one another, but they don't ever really lose contact. So they're not just flying off randomly, but they can slide past one another, which allows the liquids to flow. And then the third state of matter is gases. Gases do not have a fixed volume or a fixed shape. No matter how little or how much of a gas it has, the molecules have such a high energy and such fast motion that they will eventually reach everywhere inside a container. So gases are the highest energy of the states of matter, and they have the fastest moving atoms or molecules of any of the states of matter. And the atoms are not always touching each other. They're not in contact with each other most of the time, so not always touching each other. So they spread out. So repeat word, cross that out. They spread out to fill the entire container. And you would probably experience that. If I had a candle that had a nice scent, eventually everyone in the room would smell that scent because the gases that are coming from that candle would eventually fill the entire room. At this point, you're going to want to flip to the next blank page of your notebook because we're going to draw a little diagram that kind of shows how you go from one phase of matter to the next. I kind of call this a butterfly chart because it looks a little bit like a butterfly when it's done. So you're going to start by just labeling the states of matter. We're going to put gas at the top, liquid in the middle, and solid down at the bottom. And as you may have guessed, this is arranged by increasing energy. So energy is going up as we go. Now, in order to go from a solid to a liquid, we need to get those molecules moving faster. So to go from a solid where those molecules are locked in place to a liquid where they can move around freely, we have to make them move faster. And the way that we do this is by adding heat energy. So we're adding that heat energy to the solid until it becomes a liquid. And the process of going from a solid to a liquid is called melting. That is melting. And again, if we wanted to go from a liquid to a gas, we need those molecules moving even faster. So we're adding heat energy. Again, we're adding even more heat energy. And this process of going from a liquid to a gas is called boiling. Now, it is actually possible for objects to go from a solid directly to a gas. One of those objects is dry ice or solid carbon dioxide. If you set a block of dry ice out on the table, you will never see it become a liquid. It will just go straight to a gas. Another thing that does this is wood. When you light wood on fire for like a bonfire or for a fire to warm your house, you don't really ever see that wood melt. It doesn't go to a liquid phase. It goes from a solid straight to a gas. So again, we're adding heat energy to this, plus heat energy. And this has its own term, so it's not melting or boiling. This is called sublimation. So again, our three processes in terms of adding heat energy are melting, where we go from a solid to a liquid. I'll highlight that. So melting, going from a solid to a liquid. Boiling, which is going from a liquid to a gas. And sublimation, which is going from a solid directly to a gas, skipping that liquid phase. And all of these require the addition of heat energy. Now, everything has heat energy. There's nothing that has zero heat energy. So to go backwards, to go down the energy level, we have to remove heat energy. So if we want to go from a gas back to a liquid, we don't add cold. Cold isn't really a thing. Cold just means slower moving molecules. So we have to subtract heat energy. And it's not that we're destroying that heat energy. We're not destroying energy. You can't destroy energy. We're just moving it somewhere else. So if you have a situation where you put an ice cube into a drink, you're not destroying the heat of the drink. The heat of the liquid in the drink is going into the ice cube, which is why the ice cube melts, but it also makes the liquid in your drink colder. And the process of going from a gas to a liquid is condensation. Condensation. We can also go from a liquid back to a solid. Again, we are removing heat energy. We're taking that heat energy and putting it somewhere else. And this is called freezing. The process of going from a liquid to a solid is freezing. And just like on the other side, where you could go from a solid to a gas directly, you can also go directly from a gas to a solid. And we're running a little bit out of space. This process here is called deposition. Deposition is going from a gas directly to a solid, skipping that liquid stage again. That is going to do it for our notes on solids, liquids, and gases. Have a great rest of your day.